Determine the correct answers to fill in the blanks. Something is the risk that a bond issuer's creditworthiness deteriorates, leading investors to believe the risk of default is something and causing the yield spreads on the issuer's bond to something and the price of its bonds to something. Well, that's not default. What we're worried about here is credit migration risk. So we'll say credit migration risk is the risk that a bond issuer's creditworthiness deteriorates, leading investors to believe that the risk of default is increasing or the risk of default is higher, and causing the yield spreads on the bonds issuers to increase, or you can say widen, and the price of the bonds to decrease, or you can say drop. An uncollateralized $200,000 note has the following characteristics: recovery rate 95%, exposure at default $150,000. If the note's expected loss in the event of default is $2,500, its probability default is closest to. So we know our loss given default is going to be our expected exposure times 1 minus the recovery rate. Loss given default times probability of default is expected loss. And we just fill in what we have. We're told our exposure at default is 150. Recovery rate is 95%, which means loss rate is 5%. That's the unknown. We're told our expected loss is 2,500. 5% of 150 is 7,500, so probability of default is 2,500 over 7,500, or 33%. Determine the correct answers to fill in the blanks. While the likelihood of default for IG borrowers is typically something than that of high yield, the likelihood of default will be less than high yield. An investor's loss in the event of default for secured debt is usually something than unsecured debt, usually less than unsecured debt due to the secondary source of repayment. Well, what's the secondary source, right? Well, we're talking about secured debt, right? An investor's loss in the event of default for secured debt. What's the secondary source? Asset sale. A bond investor is considering the credit risk components and observed yield spreads for two IG bonds of similar maturity and liquidity. Bond 1 and 2. So we can get some idea of the spread. It's approximately equal to the probability of default times loss given default. So for the first one, we should have a spread of 93.75. We got 100. So we're overcompensated on the yield here. For the second one, 93.5. So we are slightly overcompensated here. On this one, you have 6.25 extra. On this one, you have 1.5 extra. Which of the following conclusions about the relationship between the bonds is most correct? An investor should be indifferent between purchasing bond 1 and bond 2, since bond 1's higher spread is sufficient compensation for the higher probability of default versus bond 2. We do have a higher probability of default, but we should not be indifferent. We get a better total yield here, 100 basis points, a better total spread, and better amount of the spread that is excess above what we would calculate that we would need. So we're not indifferent. An investor should prefer bond 2 over bond 1 since they may earn a spread that is more than sufficient for assuming credit risk. Well, that's true for both. An investor should prefer bond 1 over bond 2 since it offers the highest spread relative to the expected loss. Yes. C. Pitfalls of relying solely on credit ratings when making bond investment decisions may best be characterized as the following. Rating agencies may change a rating in response to changing market and credit conditions for a given issuer. Well, yeah, they will do that. That is a true statement, but that's not a pitfall of relying on a credit rating. Get rid of that. Credit agencies may issue a positive or negative outlook for an issuer as credit risk rises or falls, but a rating change is not yet warranted. Well, yeah, they may do that, but again, not a pitfall of relying solely on credit ratings. Ratings may involve miscalculations and unforeseen changes not fully captured in a rating agency's forward-looking analysis. Yes, that's exactly it. We're looking for pitfalls here. This one's easy. An investment-grade bond, modified duration of 7, reported convexity of 0.51, increases in price by 9.93% after a yield spread change. The value of the spread change would be closest to. We need the value of the spread change. Increases in price. Price up, that means yield down, so spread had to contract. The only one contracting is A. I don't have to calculate anything, but it does bring up something interesting here. Look at how convexity is stated here, 0.51. we would have to rescale that to 51. How do we know that? The easiest thing to do is take whatever duration you have and square it. 7 is 49, which means our duration statistic should have 2 decimals or 2 places before the decimal. Since it's 51, we just turn it into 51. But that one was easy. We didn't have to calculate anything. We would have had 2 unknowns. It would have been trial and error, in which case you would have taken the middle one and then just moved up or down depending on your answer. But because the price increased, the spread had to shrink.